Ollie. Yeah, okay. An exciting new topic, static verification. So last Wednesday, we talked about dynamic verification. And dynamic verification verify your code during runtime. Remember that you need to run your code so that your code can be tested. Right. The example we used was this one. Right. So we need to have a code, have the test, and then when we run the test, it will. When we execute the code, it can run the test for us. But would it be better if without running the code, if there's any error, or some types of error, like we can get some notes, like there's something needs to be fixed before you run your code. So this is static verification. More particular, in this course or in this lecture, we'll talk about potential errors about types. The example that we had, let me find the example. Where is it? Yep, no. Yeah, this was the example. So this is the code. Remember that we used this example a couple of times already. So this many strings is aimed to repeat the string. Oh, this is the wrong one. My code, yeah, this is the right one. So we want to repeat the string for repeat number of times. So this is the purpose of many string. And when we have many string, hello, 5, it should console log hello for 5 times. Right. So this is when everything is going well. However, if my teammates or my team member accidentally use the many string in this way, like 5, hello. Okay. What will happen? Let's have a try. 3.3. So note the file name is my code broken.js. Oh, didn't broke. 5. Oh, right. Should the other way. Should be hello and then 5. Right? And when I note it, it will console log nothing. So nothing on the terminal. So no error message, nothing was console logged. So you may have no idea about what was wrong, right? So is there any way that we can? And then 5, right? Sorry, I was looking at online. Yeah, muted. Sorry. Yeah. Cool. So is there any way that we can check whether we are using the tabs properly here, right? Because we had a string here, it can't loop through the string, right? So there's something wrong here. So this is where we introduce the static verification. So can we protect against this? So there are ways that we can do. For example, we can add a test here, like if repeat instance of number, then we console log an error, say repeat argument is not a number, right? So this is something we can do. And then we can also check the tab for the second parameter if it's a string. Otherwise, we'll console an error saying like string argument is not a string. Right? If everything goes okay, then we go through this loop and then console log stuff. Right? So this is something we can do. There's no problem with it. But is there any better way? Right? Like JavaScript is so powerful, right? NPM project, Node.js, they are so powerful. Is there any way we can do it? So we want to prevent from this kind of mismatches between the actual and expected type of variables. So C is type safe, right? So when we declare a variable in C, we need to declare whether it's integer or whether it's a long or double, like what type is it. But in JavaScript, the type is dynamic. It doesn't mean that JavaScript variables doesn't have a type, but its type is dynamic. Remember the example that we used before, like A plus 1, right? So it will be A1. Right, so its type is dynamic. So it's good, it's dynamic, it's easier, like we do not need to declare the type when we want to use it. But it's also give us this kind of potential problem in this case. So we also want to prevent this issue. So we are introducing Typescript. What is Typescript? Have you heard of Typescript? Some yes, some no. So, so Typescript is a programming language built on top of JavaScript. Okay, so to less overwhelm you, it's not a new programming language. You can think of it like a package that you install, like other package that you install. So that after you install the Typescript package, you will have you can have other possibilities around JavaScript. So you do not need to think of it like a new it is a new programming language, but to less overwhelm you, you can think of it like a package that we installed so that we have other features that can check the type for us before we execute that. Okay, and this is how it looks like. Except from the type, other syntax is exactly the same with JavaScript. So the only difference is sometimes we need to declare the type. For example, in this case, like the function sum, there are two parameters A and B, and both of them are of number data type. Yeah, so this is the only difference between Typescript and JavaScript. Like it's type safe, and sometimes we need to declare its type. So to install Typescript, we only need to run like npm install --savedev Typescript and tsnode. So this is how we install Typescript. So it's similar as when we install other npm packages, right? So you can just think of it as another npm package. And the way we run Typescript code is similar to Jest. Like when we first installed Jest, we also had like node-modules-bin and then Jest, and then the Jest code file we want to run, right? So the very similar way. Okay, so when we run npm install Typescript, under the node modules folder, there will be new folders about Typescript. So let's have a look, actually, rather than me just talking. So this is the folder that I'm going to play with. Okay, so let's install this dependency. Okay, so we added the Typescript in this project. So now when you go to package.json file, you can see that there's something new called, what was installed? So this one, so Typescript and tsnode. So now we add two dependencies in our npm project because we run npm install. And then we'll also have some new folders and the node modules, which are this one, the types, Typescripts, this one, yeah. And under the bins folder, you can see there's something new called tsnode and tsc. So these are installed when we run like npm install savedev Typescript tsnode. Okay, so after we installed this dependency, we can now run Typescript code. So Typescript code, as we have seen, looks very similar to JavaScript code. difference is that we add a tab by using column and then the tab. And our difference is we had a .ts rather than .js. So that by using the file name, like using .ts, so that Node will know that, well, this is a Typescript code rather than JavaScript code. Okay, and we can run it by using the ts. This is just my code. And stray. So the sum of 1 and 2 is stray. Okay, so this is how we run Typescript code. Similar to jest, remember that we add one script in jest so that we do not need to have the super long line in the command line. Like we add like test then jest so that we can run npm run jest or npm run test, right? But similarly, we can also have something called ts node. So this is the one that we can add to the script. So now we can have npm run ts node and then my code .ts. Oh, sorry, there's a typo. Ts node. Yeah, so stray. So it works very similar to other packages like jest, right? Yeah, jest. Okay, so this is how we run Typescript code. Another thing that magically happened was when I run npm run ts node my code, a file named mycode.js will automatically be created in this folder, which is this one. Okay, so if you don't believe it, I will do it again because it already existed before. So I will change the name to mycode -1 ts, and when I run npm run ts node -1, sorry, a typo, -1.ts. Where's my -1 ts? Sorry, my fault. So there's another way. So when we run npm run ts node my code, what happens behind the scene is it will create a JS code, and so what happens behind the scene, it will check the tab in my code -1.ts. If there's no tab errors, for example, we had hello and 5 in the wrong way. If there's no error, it will create a similar or same JS code, JS file, and then run the JS file using like node blah 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 blah. But it happens behind the scene that you cannot see it. Alright, so yeah. I hope I do not confuse you. Yeah, okay. But we'll see more examples, and you can. So, in the previous example, in this example, you can see that although we check the tab, but we still run the code. So what happens if we have something wrong? For example, mycode.ts, where are you? Oh, you are here. I'll change the name back. Oh, I don't change, just keep it. So what if I accidentally had A and 2, right, in my TS code, and when I execute the code, there will be an error message saying that unable to compile Typescript, argument of type string is not assignable to a parameter of type number, and this is the line where there's a type error. Remember in the previous example, like in the JS file, when we had a hello and 5 in the wrong order, there's no error message given us in the JS code. right, in a JavaScript file. But now we have created this Typescript file. Like we defined the type of the parameters of the variables have to be, and when there's a type error, and when we execute the code, there will be an error message saying that there's a type error on this line, and what is the exact error is. Right, so it checks for you. However, it still run the code, it still execute the code, it still happens during the runtime. So remember, initially what we want is without running the code. We only want to check the tab, whether there's any tab error. Right? So how can we do that? So the way we do that is by using TSC. So before we had ts-node, now it's another command called TSC. So let's have a look and try how it works. So TSC and then my code -1 TS. Okay, I will open here as well, so you can see the magic here. So you can see that it didn't execute a code like without all the error message that we have seen before. There's only just one error message, like say there's a tab error here on this line. So when we run TSC, it didn't run the code, didn't execute the code, but only check the tab. Okay, and here, okay, the magic is here. There's a new file automatically created called mycode-1.js. We didn't have this file before, right? Where did it come? So this is automatically created when we run TSC. So this is actually the process of how we run Typescript code. It checks its type, create a JS file, and then run the JS file. So you can just think of Typescript as another new dependency of Typescript, something built on top of JavaScript. Okay, and this JS file, this is how it looks like. A normal JS file, no tab declared for A or B. All right. Yeah, question?
How to declare variables in TypeScript?
How to declare variables? Okay, so the question is how we can declare variables in Typescript. So for example, we can have a const a, and you can declare it as a number and equals to 1. So this is how we can declare a variable in Typescript. And similarly, we can have other types. For example, const b is a string, and it should be a. Oh, sorry, q. So this is how we declare variables in Typescript. And the most commonly used tab are just number, string, and boolean, only 3. Yeah, and that should be enough for this course. Only 3 tabs, so you don't need to worry too much about it. Okay, so boolean is const c boolean equals to true. That's it. Yeah, question?
We don't need an object type.
That's a very good question. We'll cover that very soon, like how we can declare objects or arrays in Typescript. Okay, we'll cover that very soon. But anyway, this is how we can run Typescript code, like how we can check the tab before or without actually execute the code, or how we can execute the code and check the tab. Okay. Yeah, so in addition to adding ts-node to your script, you can also add another one, which is tsc, which will check your tab without executing the code. Okay, so now we can also add to our original first example for the many string. So we can say like the repeat should be a number, string should be a string tab. Right, so now if you have them in the wrong order, and when you run TSC, it will give you the error message. So it's helpful. Right? So you won't give nothing, a blank. Yeah, so you have no idea what was wrong. Actually, let's have a look. My code broken. This is the my code broken And let's try. So now we can have npm run instead of having all the line here, because we already add the scripts in the npm run. What did we add? We said TSC, just TSC. So you can have your own customized ones. Okay, so just said, oh, I run the wrong code. So it should be my code broken. My code broken. Isn't it? Yeah, that's the right one. Oh, sorry, I forgot TSC. Oh, sorry, TS. But still, yeah. So you can see that there's an error message saying that there's a tab error. Okay. So how to Typescript? So we have already seen, like, you can add a column, then the data type following. So you actually give it a tab. Give JavaScript a tab by using Typescript. But Typescript do not require you to put tabs on everything. So for example, const name is Hayden. You will see Hayden next week, by the way. So if you use const name Hayden, you do not need to declare name as a string, because Typescript will identify this by itself. So this is a string. You do not need to tell me. I already know this is a string, right? But for here, so in the function parameter, we cannot know whether name should be a string or number or boolean. So we need to declare it. So this is required. But for here, like, when Typescript can identify the type, we do not need to declare it. So we have the flexibility. Right. Okay. Cool. So some examples of typing or Typescript. So there are the most basic straight types, such as string, number, and boolean, as we have mentioned. And this is how we write functions in Typescript. So for parameters, we will require a type declared, because Typescript cannot infer the type of the parameters by itself. But the returned data type is optional, because in most cases, Typescript can infer the type of the returned value by itself. So we do not need declare that. But if you want to, you can declare it in this way. So you can add after the bracket a dot and then string. Yeah, but this is optional in most cases. So this is how we use Typescript functions. There's something interesting that we can do with Typescripts. Like, we can have units in types. For example, in this one, for the parameter ready, the type is not boolean or not number. It's boolean or number. It means that when you call printf ready, you can use 1, 2, 3, 4, 0, or you can use true or false. Either one will not create an error message, so either one is okay. So give you more options. So in the parameter, you can say dot, boolean, or number, or you can say string or number. So it can have more flexibility. So declaring the type doesn't mean that it can only have one type. So you still have the flexibility. Okay, so we had a question like how we can declare the type for arrays or objects. So this is how we can declare type for array. So for this one, we are declaring ARR array, and the type is array. And in this array, you can have values of type string or values of type number. Either will be fine. So let's have a look. So this one is a little bit different. It's called list. So, okay, let's run it. So we can, remember how we can run it? npm run ts node. So ts node will execute the file. TSE will not execute a file. So this is the difference. TS node and then example the list dot ts What was wrong? Okay, I had a typo. It should be lists. Okay, so it works well with when the input parameter 1 is a string, right? But it can also work well when we had a number. So it can create it can create an array. So this array can either be an array of strings or an array of number. So both will be fine. Okay, so you still have the flexibility. So this is how we declare array tab in Typescript. Yeah. So this one is like a new syntax that in Typescript, like we didn't see it in JavaScript, right? But you get used to it. So it looks a little bit new to you in this lecture, because for most of you, it's the first time you see Typescript, but you will get familiar to it.
Are we going to write the project in Typescript?
Yes. For iteration 2, we will change some of our JavaScript code into Typescript code. So what we are going to do is first change .js into .tes, and we are also going to add tabs in our previous JavaScript files. Yeah. Okay. This is something new, and it's something quite powerful in Typescript, is we can define a type of our own. So for example here, we define the type to be a list item, which can be either string or number. Then we can use this type in the parameter for item, and later when we declare the array. So we can reuse them. Instead of in the previous example, you can see that we had string or number here, and then string or number here. Right, so it's kind of an extract of our code, so that we can reuse the type that we defined, so that we do not need to have like a string or number here and then string or number here. So it simplifies our code, but it's basically the same thing. It's called Aliases in Typescript. Let me see how much we have left. Okay, I don't want to rush to finish everything. I think what you have learned so far is enough to support you this week.
Some more little TypeScript stuff. So a lot of what I'm showing you here, like aliases and a few of these other things, these are just so when you see them, you're like, I know what that is. But you know, 90% of the time, all I'm ever defining in TypeScript is like string, number, object, array, like on repeat. A lot of this complex stuff doesn't really come up much, but it exists. Sometimes we have functions that take in a parameter optionally. You know what this is like. You've got a parameter at the end of a function, but it's not always passed in. A good example is the substring function. So most languages have some kind of substring function where they take a string, and then they take an index in that string, treating it as an array, and then they take a length and they say, I'm going to extract that amount of data from it. It's usually how if you get a big string, like, you know, a good example is like with ZIDs, right? Like in JavaScript, let's say you have a ZID, ZID that's like, you know, my ZID. This isn't a real function, but if I call substring on the ZID, I can say, hey, go from index 1, which is the, you know, the second part, that's the 3, and then go and take 7 characters. That's like a substring function. You'll see that in languages like Python, JavaScript, Java, a whole bunch of stuff. So if I have a function like that, often the end is optional, because often like half the time that someone's calling that function, they're actually just saying, you know what, just get me from that index 1 till the end. You know, I don't need to tell you how long it is, because I just want it to always be as long as it is. Because, you know, maybe Z numbers are super long or something like that sometimes. So the end is optional. But if we want to express that in a TypeScript sense, we can do it one of two ways, which is we can either do it the way that you might have been able to figure out with the other slides, which is that we can say, well, end is either number or undefined. Because undefined, It's so annoying in JavaScript. Null in JavaScript is like saying there's a thing that exists and it means nothing. And undefined is a way of saying it doesn't exist at all, which is complete insanity as far as I'm concerned. But they do exist. And saying number or undefined is the literal equivalent of saying this will either be a number or it will not exist at all. Undefined means it does not exist. So that's how you could do it, but the shorthand version of that is to put a question mark before the colon, right? Again, you'll probably use that once or twice in your project, but if you just did the or undefined, it's totally fine as well.
So why does it, when it gets undefined, know, so I should go all the way to the end? Like
Sorry, ask me that again?
Sorry, so why, when you make the type undefined, it knows, okay, so if I don't get this, I just go all the way to the end?
Well, that's in the code that you write. It's more that, like, if you have, for instance, if you just have this as number, like that, then when it gets to this bottom one here, even if your code, right, like, even if your code, for instance, says, okay, I'm going to create a new string, and then what I'm going to do is I'm going to say the end of the string is either, you know, it's either the length that I give it, or it's the total string length, and then it just starts iterating through it. The code will do all that magic, but if you don't actually say that end could be nothing, then Typescript will catch it and say, like, you know, bad. So, like, many of you have written code, I'm sure, that takes in an optional argument. And sometimes you just ignore it. Or if it's not there, or you might have another check, you know, like, for instance, you could write code here that just says, hey, if end exists, then console log yay, right? Like, that's how you could write a function that has, like, deals with an optional parameter. It's just that if you don't then tell Typescript it's optional, Typescript will stop you. Which is, again, another great example of what will catch you on bugs in your program. Because, you know, you'll have these bugs in your program and you won't even realize it. Yep. Is there function overloading? So the question about function overloading, I don't know. I'd have to Google it. I'm not going to unpack function overloading, but most of the time, because JavaScript's pretty dynamic, you wouldn't really function overload. Maybe you can. I'm not too sure. Be worth Googling. Some languages have that. If you're curious about what we're talking about, you can go and Google it. Great question, though. Thank you. We also have objects. Now, this is probably what people care about more. I should really check I didn't destroy the stream. I really should look at the... What is the waterfall music on? No, it's not. Forgot to hit record. Oh, damn. That's okay. So if you want to have objects, generally what I recommend with objects is when you define an object, normally you say const person equals and then an object, right? But you put the type right after the object name, and then you just go and define an explicit type above it. So this is probably the first time you've seen like this little type syntax here. But this works really well. Objects are really tricky to define because, like, you could think about it from Typescript's perspective. If you have some code that says const person equals, name is Hayden, and then someone comes along afterwards and says, person.age equals 18. Like, Typescript, like, you can kind of imagine the crisis of identity. Typescript's like, if I allow age to exist, then how do I not allow anything to be added to it? And if I don't allow age to exist, then nothing can ever be added to it, So it's this kind of problem that we get around by saying, well, at the simplest level, I could say type person equals, name string, like that. So you go and define this little type up the top that like gives you the structure and the schema and the way it should behave, and then you go and create it, but this will still fail on me. So instead what I can do is I can say, well, age is going to be either a number or it's going to be undefined, So now it has a way of denoting that it might or might not exist. And this will allow the code to work, but then if you say person.height equals 12, that will fail now. So it's just, these are just ways of articulating what truth should be. Syntactically, the only weird thing you'll notice about a type definition is that there's semicolons at the end. So it's very easy for your brain to like jump into wanting to put commas there because you think it's like JavaScript. But remember, it is just a different thing. So yeah, that's a slightly more involved example, I guess you'd say. Another interesting thing is literals. These are actually really, really powerful. Has anyone ever written a function where you take in like a true or false value to represent something? Ever? It's like, that's really good sometimes, but like the problem you can have with true or false functions is if you, let's say you have a function to turn like a, I don't know, a good one is in the major project, I think, there's a function that's like, set admin status or something. This is not what you've seen so far. And you pass in like a user ID, and then you also pass in like is admin, like that. And then we say, if is admin, then we like, turn the user to an admin, like if it's true, basically. Whereas if it's false, then we like turn the user to not be an admin. So that's maybe like some function flow there. But what would be really nice is if you maybe had it as a string. So like, and this works really, because here's what happens. Suddenly now you don't just have an admin or not an admin. Suddenly now you have like an extra level of permission. Like what happens if someone could be an admin or an owner or a user? So then you think, damn, we can't use a Boolean anymore. So you say like level, and now you're like, well, okay, well if the level is owner, then we go and do like owner stuff. And if the level is admin, then we go and do, admin stuff. And if the level is user, we do user stuff. What's the problem with this though? The problem with this is that what if someone passes in gibberish or a string that isn't one of those three? Well, then you think, okay, I'll go and do some checks, like here, like an else statement. That's like, ha, got you. But the problem is, this is like week one thinking, this is like dynamic checking. This is us checking at runtime. So then we think we're going to use Typescript now to solve this problem. So what do? Obviously, we go and put like string up here. But what's the problem with that? They can still put in gibberish. Because we don't just want it to be a string, we actually want it to be specifically one of three things. So in this particular scenario, we can get around that by actually explicitly writing them out like this. Because any literal thing can be its own type. You can do this with numbers, you can do it with anything. We call these literal types because it's not just like a string or a number or something. We're like, no, it literally has to be one of those three values. And that in itself, we've created a type. And then if I wanted to just abstract my code out literally, I could say, level perms or like level permissions. And I just go and grab one of those three things like that. And then here I say, yep, my level is level perms. And maybe I'll just throw in user ID as number for good luck. So, that's kind of how you might be able to use Typescript to contain that code a little bit. Yeah. Questions?
So is it similar to like enums in 1511?
I don't know exactly what you do with enums these days in 1511, but yes, it would be. Like it's a way of kind of constraining it down. Like everything we're always trying to do is constrain it, because then anytime someone does anything that's slightly off that mark, they immediately just get an error, which is what we want to see. Just while we're chatting, I'll give you some, just for like an example. If I go grab my code base from work, I don't know if I have the latest one. I'll just check. I don't think I pulled on this laptop in a little while. So it's gonna have a bit of a time here. Ooh, okay. So we've done like literals. Last couple of things, any. So any's this kind of thing. I probably should put this slide up the front if I'm being perfectly honest. But any's this thing you can go and you can put throughout your code. And what it does is it basically shuts up that thing where we don't like when you don't define a type. So like when TypeScript's like, I don't know what type that parameter is, you can just go put any there, and what it is, it's a signal to TypeScript to let anything through. What's the use of that? Any ideas? What a perfect answer. So sometimes it's to write the code first and then figure out what it is later. Now, this is much more important for code that does type checking when you run it. It's probably less important for your project because we we don't check that. But this is super useful because there are definitely environments and projects I've seen people set up where the code won't run unless it's type safe. So any is a really great like kind of temporary plug. It just says like, yeah, just accept anything, just be JavaScript for a minute. We'll come back to what this is later. So it's great in that particular scenario. And that's actually all the examples we have. But hopefully now I pulled, oh my god, it aborted. I've never had a git pull be so big that it's aborted. Okay. That's a bit weird. I'll figure out what that is later. I'll show you that next week. I'll show you what like a production-sized TypeScript running does. Okay, so some summaries here. Type safety, a summary of language in the type safety. C, Java, Haskell, they all have non-optional built-in static typing. They require types to operate. Then you have languages that have optional but still built-in static type checking, which is TypeScript and Objective-C. And then you have languages with optional external type checkers like Python and Ruby. It's a little bit deceiving there, that list, though, because like you could argue that TypeScript is just an optional external type checker to JavaScript, which I think is how it's worth thinking about. It's like Jest. It's something you add on to it. But a lot of people will talk about TypeScript like it's a language. Has anyone got friends at uni who are like, oh, I learned TypeScript, and it like sounds like another language to you? I'm sure you've had a couple of you have had that. So TypeScript, people talk about it like it's its own language, but in reality, it's just a little bit of syntactic sugar that goes over JavaScript. So when someone says, I know TypeScript, all they're really saying to you is they've learned JavaScript and they know how to add types to their JavaScript. That's the whole story most of the time. This slide you don't need to read. That's just more like some background for you. But here's where things get kind of fun and interesting. How I was running TypeScript earlier, if you pay attention, was that I was running it on the terminal like this. We can do exactly what we did with Jest, where we actually add it to our package.json, where we say here that when we run TypeScript, I'll just get rid of this. When we run TSC on the terminal, I want to run TSC, and when we do tsnode, I want to run tsnode, which makes your life easier now, because rather than running all that complicated stuff, if you just want to type check your project, you can just run npm run tsc, and that will go and that's okay. It will go and run TSC on your whole project. And similarly, if you do npm run tsnode on a particular file, it will just go and run that for you. So you don't need to worry about all that node modules bin stuff. It's exactly like Jest. And all you have to do is add it to scripts. And we either do that for you, or we tell you in any labs or assignment how to do that. So that's not something you need to kind of stress that you aren't absorbing super quickly. So the last point I wanted to make here was that, and I won't do the demo just because I find these in-person lectures, I run a little more behind than I think, because a lot of these lectures were written when we were doing everything online. And you always ask so many interesting questions in the lecture, which kind of kills 10 minutes typically. You can actually add it to your pipeline. Remember on Tuesday, what day is it today? Friday of week 3? When did we talk about CI, wasn't it? Was it really this week? Confusing myself now. So we talked about, it feels like forever ago. Oh my god. So TypeScript, TSC, you can actually add that to your GitLab CI thing. Now, many of you haven't done that at all yet, obviously, because that doesn't come up till week 4. But I'm just trying to demonstrate for you that there's a lot you can do with these pipelines. Because when we do that pipeline lecture, we're like, you can run Jest automatically, and there's always like 2 people, I can see them in the back being like, wow, that seems really useful, Hayden. I don't have to type 10 characters on my keyboard. But it grows pretty quickly, you know, because like as we learn these things, suddenly it's like, okay, now we're not just automating the running of our tests, but we're automating the running of TSC. So when you're pushing code up to a merge request, now GitLab is suddenly having the ability to not only type check your code, but also run Jest on your code, and then another thing, and then another thing. So we can always just keep layering these checks or these tooling abilities, you know, as we go.